So this is the second part of the quick revision on previous trig topics, and we're going to be looking at SOHCAHTOA, or these ideas about sine, cosine, and tangent. Remembering that these are tools that we can use to figure out information about angles and sides of right-angled triangles, and again, right-angled triangle only. So first thing that you'll want to do is actually label the information on a problem. And when we think about these, we're looking to label the opposite, the adjacent, or the hypotenuse of the triangle. And if you remember correctly, the hypotenuse is always going to be the longest side of the triangle, or the side opposite of the right angle. And the other side I'm going to label is the one that I don't know here, the x. So the 15 is the side that I know, and the x is the side that I don't know, and this one is actually going to be opposite. And the reason I'm going to call it opposite is because it's across from the 32-degree angle that I've been given. I know 32 degrees, and the x is across from it, or opposite it, like the 32 has to reach out across the triangle and wave at it to get it. So I know O and H. I'm not going to worry about labeling this bottom side because I don't have any information about it, and I'm not looking for it, so I'll just ignore that. And since I've got O and H, I'm going to look up and see which rule I can actually pick from. So in this case, this would be sin, or sine theta, and I have O and H, which is exactly what I'm looking for, O and H. If I had A and H, it could have been cosine, or O and A, it could have been tangent, but here I have the information about O and H, so I'm going to use the rule for sin, SOH. And what I'm looking for is the opposite, so I will cover it up. And remember that when I'm using these triangles, I can times across the bottom. So what I'm saying here is that the opposite is equal to sin of the angle 32 times the hypotenuse, which is 15 centimeters. So I'm going to go sin 32 in my calculator times 15, and I will get 7.9 centimeters. So again, going by labeling the information that I have, or that I am looking for, the x and the 15, finding out that I have O and H as important sides. From there I picked sine, because I have O and H for my sine ratio. And then I use the triangles and make sure that I always times across on the bottoms. And had I been doing division, looking for something else, you divide across at the top. Always dividing what's on top by what's on bottom. So let's look at another example. Taking a look at example 2. Here we've been given some information again about a right angle triangle. So I know that I can use sin, cosine, or tangent, or Pythagorean theorem information. And in this case I've been given an angle, so it's probably going to have to do with sine, cosine, or tangent. And I am going to be, for my first step, labeling the information that I have and the information that I want. So I'll notice that I've got a 29-meter side, and that is actually going to be the adjacent side because it's touching. It literally rubs up against the angle I've been given, so that's an adjacent. And then the z is actually a hypotenuse because it's across from the right angle. It's the longest side of the triangle. So if I think about my ratios, so, ka, or toa, here I've got the information of A and H, so I'm going to actually use cosine because it's got the A and the H in it. So here, looking for what I am looking for here in this case is H, so I'll cover up the H. And using that formula, I know what I'm going to have is A divided by C. So we can write that as 29 divided by cosine of 58. And if we plug this into our calculator, we get 54.7 meters. So again, here I have an A and an H, and because I'm looking for the hypotenuse, I cover it up and I'll use division. And it's always the top thing first, so the 29 divided by the cos 58. If you do it the other way around, you get a different answer that's not correct. Looking at the last example here, we've got, as a first step always, to label what we know and what we don't know. So here I notice that I've got the adjacent side again. Because it's touching the angle, it's between the angle that I've been given and the 90 degrees, so that's A. And I also have, in this case, the opposite, because it's across from the angle. It's on the opposite side of the angle we know. So here, I'll use tangent for TOA, because I know I have an O and an A. And the one I'm looking for in this case is A, so I'll cover it up. And this ratio, this formula triangle, will tell me that I need to do O divided by T. So what that means is I'm going to go 45 degrees divided by tangent of 37. You always have to give the tangent or the cosine or sine, whatever it is, the angle, the size of the angle. So 45 divided by tangent of 37 is going to be 59.7 degrees. And that is equal to our adjacent side, or the x that we don't know. Sorry, it's not degrees, my bad. It's not the angle we found, it's the side. So 59.7 meters. So taking the sine and cosine one step further, let's look at finding angles. All the examples we've done previously have been for finding sides. So when finding an angle, we use the same information, just have to use the formula slightly differently. So same thing occurs, we label the sides that we know. So in this case, I've got the adjacent side, and also it's opposite the 90 degrees, so this is the hypotenuse. This is the adjacent because it's touching the angles between the angle I'm looking for and the 90 degree. And this is the hypotenuse because it's opposite of the 90 degrees. So thinking again about which ratio I'd use, I'll use ca, or cosine, because it's got the information that I need about A and H. Now to find the angle, I'm going to cover up what I'm looking for, and in this case it has to do with the cosine of the angle that I'm looking for. So when you do these, we have to use inverse cosine, but to write this formula out, I'm going to say that the angle Z that I'm looking for is equal to cos inverse of A over H, which is 16.2 divided by 28.5. So we use the inverse to tell us what the size of the angle actually is. So if I plug this into the calculator, I will get Z is equal to, in this case, 61.4 degrees. So again, I have to use the inverse cosine function. You'll find that using the shift button on your calculator, and that tells me what the angle is. So Z is 61.4 degrees. Looking at our last example, here I've been given the angle K that I'm looking for, so that's what I want to know. If I identify the information about the important sides, I'll notice that K is looking across the triangle at 75, so 75 is going to be the opposite side. And K is touching up against the 40.9 degree, or 40.9 centimeters, so this is going to be the adjacent side. So in this case, I will use tangent, because that has the information about opposite and adjacent. And here I'm looking for the angle, so again I will cover up the tangent part, because that's where the angle hides with the tangent. And I have to use the inverse. So K is equal to tangent inverse of the opposite divided by the adjacent, so in this case 75 divided by 40.9. Using brackets, when we plug this into our calculator, you will get 61.4 degrees. Which makes me notice something, that I accidentally wrote down the wrong answer up here. Sorry to leave you hanging on that one. That was the answer for the next one. Cosine inverse of 16.2 over 28.5 should be 55.4 degrees. So sorry about that mix-up. Okay, so that's a quick recap for us of Pythagoras and using sine and cosine. Where we're going to take this is to new rules about sine and cosine that we can use with non-right angle triangles. And just to solidify this revision, let's go ahead and look at two little word problems. So pieces of a concrete curb, 32 centimeters wide, are designed with a gutter to drain water. The gutter cross-section is an isosceles triangle, so that's like taking the gutter and cutting it in half so we can look into it. And we see an isosceles triangle, which means two equal sides, and we see that here with those hashes. Calculate the depth of the water when the gutter is full. Okay, so the water is going to fill up from the top down to the bottom of the gutter here, that will be the depth of the water. And looking at this, currently right now, we only know information about Pythagoras and sine and cosine, so I'm looking at it knowing that I do not yet have a right angle triangle, so I'm kind of stuck. But if I think about that line I just drew in to find the depth of the water, you'll notice what? That I get a right angle triangle. So I can actually create a new right angle triangle. That's just half of that isosceles. And I know that 148 divided by 2 is going to give me 74 degrees, so this part of the angle would just be 74 degrees, half of it. There's my 90 degrees. And 32 is all the way across, so if I cut that in half, I get a 16 for my length up here. So just taking this part of the triangle and looking at it as a separate thing. And I want to actually know the depth here, the depth of the water in the tank. So again, thinking about my rules, I've got an angle here, so I'm going to be using sine, cosine, or tangent. I notice that I have the opposite side and also the adjacent side because it's touching the 74. So I will use tangent. Taking a look at what I'm trying to find, which is the adjacent side, I will cover that up. And I notice that the adjacent side will be equal to the opposite divided by the tangent. Remember, it's tricky, but you always start with the one on top, the opposite, 16, divided by the tangent of the angle 74. And 16 divided by 74, divided by tangent of 74 is equal to 4.59 centimeters. So in a sense, that's approximately 4.6 centimeters deep for the water. And looking at the last problem here, this is about bearings, and we'll do bearings a little bit later as well, but to remind ourselves, bearings are always measured from the north. So if I think about that arrow pointing straight up, the bearing will always be measured from north down around to the angle. So that's why the bearing looks like that. An oyster boat leaves Bluff and travels on a bearing of 161 for 4 kilometers. The bearing of 161 is actually the size of that angle from north all the way down for 4 kilometers. How far east is it from the starting point? So remember, never eat soggy Weet-Bix. So east is going to be in this direction. And if I think about trying to complete the diagram a little bit for myself, what do I find here? I can find a right angle triangle. So again, I can use all these rules that I know. But I need to pull out some information. So the 161 degrees is from north all the way around, and that's not really helpful for me. But I know that from north to east is 90 degrees, so if I do 161 minus 90, I get 71 degrees. So I know this part of the triangle here is 71 degrees. And now that I've got that labeled, I've got some information inside of my right angle triangle. 71 degrees, I know I have the longest side there, the hypotenuse, is 4 kilometers. And this is the side that I would be looking for, the eastern side, and that's actually touching the 71 degrees, so it's going to be my x, or my unknown. And that's also the adjacent. So here I'm going to deal with cosine, because I have a and h. And I am looking for the adjacent side. So here, x, or my adjacent, is going to be equal to cosine of 71 times 4. And cosine of 71 times 4 is going to be equal to 1.3 kilometers. So in this case, the boat will have traveled 1.3 kilometers to the east.